Alright, hello and welcome to the programming lecture for the week. I'm going to try and do one regular lecture that doesn't include programming and then one programming lecture each week. I'll try and stick with that. And so, welcome to the programming one. Here are my goals for you. My cat is scratching my chair, and let's get started. So, we're going to talk about programming, and I'm honored if I'm the one who gets to teach it to you and you haven't learned it before. We're going to start from basics. Okay, so what even is a program? What's an algorithm? So think of it like a recipe. Okay, so an algorithm, let me put that in bold. An algorithm is just a sequence of steps. So it's exactly a recipe. It tells you how to get from point A to point B if you're trying to do something, to complete some task. Okay, so my question to you, and I would ask this in class if we were actually in a class, I'd have you get into groups and come up with your algorithm for how do you make a peanut butter and jelly sandwich. So it's harder than you think. So maybe take a second, pause the video, come up with an algorithm for making such a sandwich. Okay? So I should be hiding this stuff, but I'm not currently. So I think if you're anything like me before I learned to program, this would be your algorithm. It would be something like, all right, you're going to make peanut butter and jelly? Sure. All you got to do is get the peanut butter and get the jelly, slightly smaller jar, right? And then you just put that on some bread and voila, you have peanut butter and jelly. Well, if I were a computer and I were executing that algorithm, that program, I would get the peanut butter, get the jelly, put it on some bread, which is in the bag still, and voila, let me see the slices, voila, it was so simple. I have made you peanut butter and jelly. Obviously that's what you wanted, right? So, I don't think it was. And the takeaway here is that a computer is very smart but very stupid at the same time. So it's going to follow your instructions to the letter. So if you say put peanut butter and jelly on bread, it's going to do that exactly, okay? You need to be a bit more specific. You need to say, okay, you need to get the peanut butter out, put it on a plate, or get the bread out, put it on a plate, 2 slices, take the peanut butter out with a knife, same with the jelly, put 1 on each slice of bread, and you can get even more precise than that, so on and so forth. So that's the idea of computational thinking. So you need to think computationally when you're writing programs, when you're making recipes, because the computer is going to follow your steps exactly. And that might make weird things happen. Okay, so the key thing that I want you to always do when you're writing a program is to break down every problem into very small steps. That's very important. And be very specific about how you move around between those steps. Okay? So that will get you very far in your programming career. Okay, so that is peanut butter and jelly algorithms, programs in a nutshell, and we're going to learn something called Scratch today. So it's a graphical programming language like I was talking about before, and it's block-based, we say. So you can pretend there's little blocks that you're stacking, and they create the program. Okay, so let me draw some blocks now, and they all fit together. Okay, so this is one block, and this is a second block, and they all fit in a nice way. Like this is the second block right here. This is the first block. They're all like, they fit exactly like puzzle pieces. Okay, and then here's the last block. And the idea of a program is each of these blocks does one job. Okay, this thing does operation 1, this thing does operation 2, and this thing does operation 3. And the fact that operation 1 is on top of 2 and 3 means that it happens first when the program runs. So there's a bit of an ordering going on here between 1, 2, and 3. They happen in top to bottom order. Okay? So that's the first piece of the puzzle. The first element of terminology that we're going to learn in this class is when you run a program, you say run, at least as long as we're talking about Scratch, not run, that means perform the operations. Alternatively, we say execute. We're not like killing the program, but we say execute as a synonym for run. execute these 3 blocks in order. Okay? And the in order part is super, super key. In order. Yeah? That is the idea. So all you're going to be doing for the first few weeks of programming in this class, if you're not coming from CSCI 40 and getting fancier programming assignments, is to manipulate these blocks in a way that gives you a nice program at the end of the day. Okay? So just think of it in this form. You're going to make some programs that are just blocks. They all fit together, and running the program executes each of these blocks in order. Okay? That's the idea. So let us get started. And the first thing that I want to show you is a program called Hello World, because for no good reason, it's just customary. Whenever you learn a programming language, the first thing that you're supposed to teach someone, if you're the teacher, is to make the program output the words, like have the program talk to you, like prove that you can do at least one small thing. And it's usually like you pretend that the program is sentient and they are saying back to you, hey, hello, I have life now, hello world. Okay, so that's the first thing that I'm going to show you, and after that we're just going to play around. Okay, so let me show you this program very quickly, and then we're going to get into detail with Scratch. So I gave us some links here, and go ahead and follow them. The first one is the main Scratch website that you'll be going to. You're going to write your programs on a website. Okay, there's also a program that you can download if you'd like. You click Start Creating, and then here we are in the Scratch world. So if I close this, we see on the right-hand side there is a cat looking at us, and this cat, its name is Scratch Cat. Okay, and there's a whole amount of like stories, lore behind him. The Scratch Cat is non-binary, but a lot of people use male pronouns for it or him. Okay, so that is the Scratch Cat. He doesn't have to stay in every program, but he can if you want him to. And right now his name is Sprite1. An image in your program is called a sprite. Okay, so I want to get him to say hello world. And the first thing I guess I should show you is, where do we write our programs? There is a left-hand side, a middle, I think you can see my mouse. There's a left-hand side with a bunch of program pieces, little blocks. There's a right-hand side with the Scratch Cat and some different names and toggle things. And then there's a middle part. The middle part is where your program lives. Okay, you're going to drag these blocks out. Oops, if I can get it to work. You're going to drag the blocks out here and they stay. And those become your program. Okay? I'm going to delete it for now. But that is essentially all you're going to do. And then the program, when you run it, what happens is, this is the window right here where the Scratch Cat is. That's the window where things happen. Your blocks affect this scene. Okay? So that is how the program is going to work. And so my job for you right now is to teach you how to get the Scratch Cat to tell us hello world back to us. Okay? So I'm going to scroll down here, and, well, there's something called say. I'm going to say hello for 2 seconds. Not just hello, hello, comma, world, exclamation point. I'll zoom in a little bit. And this is my block, and it's all I need. Because if this block runs, I think you can imagine that it's going to do the right thing. Okay, so if I click it, it will run this block, and the output, the execution of the program, will happen in the window where the Scratch Cat is right now. Okay, so I'm going to click the block, and he says hello world for 2 whole seconds. Okay, that's your first program. He has talked to us. Check. Let's move on. Now we're just going to mess around for a little while. Okay, so let's go through all of these little blocks here. So I'm going to delete this. Or we'll keep it. We'll keep it for now. The Scratch Cat can do so many things. He can say hello just by himself, and I think this, when it's without like a time amount, it's just going to stay there forever. So you might prefer to have it say hello world for a certain amount of time, like 5 seconds. And I click this, and it says it's running, it's highlighted in yellow, and it goes away after 5 seconds. Okay, so that's cool stuff. Looks, I think you'll enjoy. Okay, motion is probably the coolest one, and that gives us animation. So this move block will tell the Scratchcat when it runs to move 10 steps. Okay, so if I click it, it's going to run this block, and the Scratchcat will move in the current direction where he's going. Okay, so there he is. He's sliding along. I can bring him back. And so we can give him a name. All this stuff on the right is customizable. So we can call him Scratchcat. And we can set his position, like where he is in the world. Those X and Y coordinates, they change. And we can show him and hide him. We can change his size. It can be 200. It's a giant cat now. And we can give him a direction, which we can type in a number, or we can use this to swirl him around. And this is just how he exists. Okay. So let me get him back to 90. And he can move 10 steps. He can say hello world for 5 seconds. And, well, that's essentially the game. I mean, I can make a bigger program by combining these blocks. And that's how we make cool things happen. Okay? So, now I can click this, and it'll move 10 steps and also say hello world for 5 seconds. See that? He moved for a little bit, and now he's saying hello world for 5 seconds. So that is beautiful. This is how we can chain things. Okay? So, before we play around some more, let's just take stock of what we have kind of experienced so far. We'll get to this in a second, and that, and that. I want to first write a comment. Okay? So a comment is just a note for the programmer, and it tells us like what we were thinking at the time. So I can right-click on these blocks and add comments and say, oh, move the Scratchcat in his current direction. Okay, so that's a comment on this block. And I can also move it around. This does not affect the program at all. It's just a note for us. So it looks like a little post-it note. Okay, so that is that. And we can comment whatever we want. Like this says hello world. And we can talk about our intentions. Like we want to say hello world for exactly 2 seconds after, I don't know, after moving 10 steps. And remember that these things happen in order. That's the point. So, and I click on this and it does it all over again. Let's have fun with these other blocks now. So we can turn. I can just click it. I don't have to drag it out just to experience what's going to happen. So here is the Scratchcat. Every time I click this, turning exactly 15 degrees. And you can see his direction changing if you look down there. Whee! There he goes. There he goes. And so maybe after he says hello world, we want him to turn 15 degrees. And you see, he had to wait until he was done saying hello world. That's the idea. So maybe we can start out turning a weird way, then we'll move back. Who knows? Okay. Go to random position is fun. If I just click that, the Scratchcat will fly around somewhere on the screen to a random spot. That's useful. Whee! There he goes. So that's fun stuff. We can tell him to go to a certain position, and that is given by an XY coordinate. So down here, if you can see, there are XY coordinates for this current sprite, for our Scratchcat. So he exists in a little world for himself, in a little graph world. So here is our cat. I don't know. I do not know how to draw him by not looking at him, but this is a cat. Sure. There he is, and he lives in his graph. Okay, so he exists at a certain coordinate. His center does. And that is how we can move him along. Okay? If that were actually centered at the spot where I wanted it to be. So let's pretend that he is at, I don't know, he could be at 0, 0, but he's somewhere. There are X and Y coordinates at play here. Okay? So that is the Scratchcat. Fun stuff. Moving on. So we can tell him, okay, well maybe he starts here, but I want him to go to way over here, like 168, -2. So I'll put him back here, and I'll say, okay, go to 168, -2. and I click this, and from here, he will go there. Straight there, always there. If I put him up here, he'll still go to that same coordinate because the coordinates never change. Go to is like immediate, like he teleports. Glide is a bit smoother. Okay, so if I can delete this one, we'll try gliding instead. Here he is. It'll take 1 second to glide to these coordinates now. Ooh, that's smooth. I like that. Okay? Doesn't matter where he starts, he'll always glide to that spot. And it'll take him 1 second to glide there. Okay, so I think you can kind of see what's happening. Change x, change y, change x by 10 will move him to the right, always, no matter what his current direction is. Whereas move 10 steps always moves in your current direction. So if he's this way, and I move him, he's pointing. He's going to walk the way he points, is the idea. All right? Get him back to 90. So I really encourage you to play around with this stuff. This is how you learn. You can change x, change y, set x, set y to whatever you want. But 10 is fun. He like levitates. Bouncing is going to be fun. We'll get into that. These are variables, which we'll talk about later. Cats. He can have costumes, in fact, which is fun. Costume 1, costume 2. He's like running. So sprites can have different costumes and you can swap between them in your program. Why not? We can change his size by 10, by -10. Click, click, click. And now he's like going into the Z direction. Or you can immediately set his size to exactly 100. If you were smaller, he'd just pop back to 100. Color effect is fun. Like he changes colors, and you can reset it by clearing the graphic effects. You can show and hide the scratch cat, hide and show. And layers are not too important at the moment, but they will be once we add more sprites to our program. You can't hear this, but he can play sounds, like there's a meow sound, or you can record your own and change the way the sound works and the volume. Events are going to be the fun thing that we're going to talk about later. I think the rest of this is something for another day. So the motion stuff is where I want to stop. Okay, so on to events now. So really, I have made a program. So first, the scratch cat will turn 15 degrees, then he'll move 10 steps in his current direction, which is right. He'll say hello world for 2 seconds. There he goes, saying hello world after rotating. Then he will turn 15 degrees to the right, switch to his running costume, and then he'll glide to this coordinates 168, -2. Okay, and I've added some comments. So that's a pretty complicated program, but we have been cheating. So you're not really supposed to run the program by clicking on the blocks. That's not right. Okay. What is supposed to happen to start the program is an event. Okay. So clicking on a block to run it is not really the right thing to do. That's not a program really. So instead, we'll have an event to start our program, and the most basic event is the green flag. Okay, so we're going to drag this one out, and events begin a computation. So you can see how this set of blocks is kind of waiting for something up here at the top, and the events are those things that like kick off the computation. They don't have little spots where things can go on top of them because they begin everything. Okay, so here's the green flag right here. It's supposed to start the program, and you can see it says go when I highlight over it. So now when I click go, it's going to run this entire program to do all these weird things. Maybe we can switch him back to costume 1 before it starts. And so when I click go, he'll start here, do all this stuff, and he'll end up, the very last instruction for him to do is to glide way over here. Okay? So I think you saw it all happen before your eyes, and that is essentially our first example. So you've made it through, you have programmed. If you followed this, you're well on your way. Okay? And if it's still fuzzy in your mind, that's why I have 2 more examples at least. Okay? So don't worry. We'll get through this. All right. So Now I want to give you a more complicated example. The first thing I'm going to do, and something that you will want to do if you want to like save your work, is to save to your computer. You say File, Save, and you can go to Save File. Okay, it's called. It gives itself a silly name, but you can call it whatever you want. And who knows where that just went? Maybe I accidentally clicked Cancel. I would like to save the file, please. Oh, it just already downloaded, sorry. And so this file you can go and change its name, and you can load it. Like you can come back later, come back on a different computer. You can load from your computer your program, and it'll be exactly as it was where you stopped. And you can start off again wherever you want to be. So now I'm going to clear this out because I've saved it. Okay, leave the page, click the home button, go to start creating again, and here's my idea of the next example. Okay, so the Scratch Cat is hungry, and he will get a banana from the fridge. Okay, so he's going to walk over to a fridge and grab a banana and go walk away with it. Okay, so the first thing that we'll need to set our scene with a different backdrop. Right now, our backdrop is white. So it's just a white screen, and we don't want that. We'd like a different one, please. So you can choose a backdrop, and if I remember correctly, there is one with a fridge. So we need to find that. Refrigerator, cool. There he is, awesome. So here he is over here. He's hungry, it's gonna walk to the fridge, and there's gonna be some food in here, and the food is another sprite, because we want it to move. Okay, so we can add another sprite, which is another image that can be animated. We can actually paint our own if we wanted to. We can get a random one, so maybe we can have him pick a wizard out of the fridge. But no, let's find some food and choose a sprite. There are my bananas. Cool. All right, are you ready? So here's some bananas. We can add more things to the fridge. He just doesn't have to eat all of them. Add an apple. You can change its size if you think it's too big. Like maybe it should be only half its size right now. Banana for scale. Okay, so we're gonna have the Scratch Cat walk over, get the bananas, and then walk away with them. That is the idea. And so we have to come up with an algorithm to do this. We know the very first thing that needs to happen is the program starts. So we'll have it start when the green flag is clicked. But we need to now move the Scratch Cat and then move him back with the bananas. Okay? How will we do this? Okay. Here is my algorithm. So we're going to start out the bananas in the fridge. You'll see why that's important later. We will have the bananas wait 2 seconds to start moving because the Scratch Cat needs to move over there, and we'll give him 2 seconds to move over there. And then we'll also move the banana to the same place that the Scratch Cat is going. Okay? And the banana will take just as long to get there. So that's my little algorithm, and that's enough for me. Maybe you would like to write more comments. These are enough comments for me to go and start implementing. Okay? So when in doubt, be very, very wordy. Okay, so here are my bananas. Here's my Scratch Cat. I'd actually like the bananas in front of the Scratch Cat, so now I can show you things. I can show you that one block that we were talking about, or wherever it was. Go to the front layer, please. So now the bananas are at the front. So I never need to run that again. No darn. They're always going to be in front, I sure hope. No, they're not. Who knows? We'll figure it out later. All right, so bananas, they're in the fridge. They need to start there, and we need to move the Scratch Cat to the fridge. So let's do a few things. Okay, so when the green flag is clicked, I need the Scratch Cat to move over here. Okay, let's have him move right here, and the direction should maybe be the opposite way. So maybe he should be boop, like that, if he could be. Maybe he should be mirrored. But I don't think we're allowed to do that. Maybe, if only. So we need to move him right here, and I'll keep him at 90. And so it looks like the coordinates are -193 and -107. So the very first thing that happens is we want the Scratch Cat to, I don't know, he could say he's hungry. We could have him say that if we'd like. Or he can think he's hungry. for 2 seconds. We're going to have to change the program though. And then he needs to walk over to this 193, negative 193, negative 107 coordinate. So we'll have him glide, and we'll have him take 2 seconds, because he's not running. He's hungry. He doesn't want to expend his energy. So if we start him over here, we click the green flag. He's like, I'm hungry for 2 seconds. And then he does like a moonwalk over to the bananas, and he wants to pick them up and walk away with them. So maybe he just picked them up, and we can have him glide back to where he was, away from the fridge, which is maybe, I don't know, over here. 181, negative 118. That's not too bad. Okay, he'll do that, and well, let's have him take 2 seconds again. But again, we are affecting the scratch cat right now. Every program, there he goes, and he's walking away, but he doesn't have the bananas, because this program is only for the scratch cat. Sprite 1 is his name right now. Let's call him scratch cat. That is an issue. Okay, so each sprite gets its own little program. Okay, so let me put that up here maybe. Each sprite gets its own separate program. So the one that we've been writing so far only affects the scratch cat. That's no fun, because we want it to affect the bananas as well. Okay, so we're going to give it its own little program. So what we want is, okay, an event. So when the green flag is clicked, we want something to happen to the bananas as well. We would like them to move over. So the bananas need to, like, they can start here, but they need to end up with the scratch cat, which is like over here, 193, negative 119. So at the very end of the day, we want it to go to, or sorry, not go to, but to glide to over here. Maybe taking 2 seconds again. Okay, so we start the bananas over here, start the scratch cat over here. Now, here's what happens when I click the green flag. It'll run this program, and if I click on the bananas, it'll run this program. So when I click the banana, click the green flag, we know what's going to happen here. Then we know the bananas, oh, they moved a bit too soon, it seems. We would like them to follow the scratch cat, so they kind of need to wait for him. Okay? So let's go back here, adjust our plan. The bananas should wait for 4 seconds, because we want to wait for the scratch cat. Okay, because we take 2 seconds to think that we're hungry. 2 seconds. And then 2 seconds to move to where the bananas should be. Over here. And then 2 seconds to walk back. So we need the bananas here to wait for 4 seconds. And there should be a wait somewhere. We will find it together. There it is. Control. Wait a certain number of seconds before doing things. Before doing the rest of your program, please wait 4 seconds, bananas. So now, I think, if we click the green flag, it will think I'm hungry. The scratch cat will think I'm hungry for 2 seconds. Glide to the bananas, and then glide back. And the bananas will wait 4 seconds for the scratch cat to be over here, after he thinks and glides, and then it'll glide back with the same amount of time to the same position. So I'm going to click this green flag, and drum roll. Oh yeah, that's beautiful, isn't it? That's the first cool program we've learned. Okay, maybe we don't want the bananas to be in front, actually. We can have them be in the back if we'd like. Let's try that. Go backward a layer, bananas. There you go. Who knows? We could have them be in front. Who cares? Okay, so we have the scratch cat, we have the banana, and if I click this green flag again, there's an issue. Can you see what it is? The bananas don't start in the fridge anymore. That's a huge problem. So, and that's because after the end of this other program, it's already over here on this right side at this particular coordinates. So if we want the bananas to always start in the fridge, we have to make sure that they're there in the fridge. Okay? So the way we do that is to start out at the beginning of the program, make sure that the bananas are where we expect them to be. Okay? So now, when I click the green flag, the bananas will always first teleport to this spot where it is right now, if it's not already there. Okay? So I'm hungry. Scratch Cat will go to the bananas, walk away with them. And now if I rerun the program with the green flag, both of these programs will run at the same time, but the bananas will first go over here. You see how they teleported? That's perfect. That's exactly what we wanted. Okay? And it looks like the cat is bringing the bananas with his mouth, which is probably what he would do in real life anyway. So that's perfect. Okay, so that is our first real example program. I'm going to save this so I don't forget about it. There we go. And we're going to move on. Okay, so one thing that I want to talk about is initialization. The next example is called alien abduction. But before we get there, I want to talk about initialization. Okay, so what we just did with the bananas, for example, is this process. We initialized not a variable, we initialized a sprite, essentially. We gave it a starting value, okay? So for example, we put the bananas in the fridge. We made sure that the bananas always start out in the fridge at the beginning of a program. When the program starts running. Let's say. If you want to get technical, you say begins execution. Okay, so essentially we initialize the bananas. So if we wanted to get fancy, we could also initialize the Scratch Cat, but unless you stop the program too soon, he's always going to start out in the right spot. But if I start him here, now he'll begin from there. You see that? Stopping the program in a weird spot. So maybe you want to start with the Scratch Cat over here too. Maybe that's what we want. We can always make that happen as well. Maybe I should save that one instead. Okay, so finally, for the last programming example for at least this lecture, what I would like to show you is alien abduction. It's a bit far away from Halloween at the moment, but it's still my favorite holiday, so we are going to have like a UFO theme. So the idea is we're going to be in some kind of field, and we're going to have the Scratch Cat get abducted. So there's going to be an alien spaceship, and it's going to appear, swoop down. So let's keep this in mind. We got to make it appear out of thin air, of course. Then it needs to like come down, move closer to the ground, and it needs to like send out a beam, of course. And here's our cat. And then the cat needs to start like moving upwards. Glide the cat upwards. And this is the planning stage for our program. I hope you see that. And then maybe the beam goes away, and then the UFO goes upward or something. So like beam disappears, and then eventually like UFO leaves as well. Or glides away or something. We'll figure this out together. And I would ask for your opinions if this were in a real class environment. So let's go back here, make a new program. Maybe I can just say file new. Yeah. Okay. So how do you want to do this? So the cat's fine. Cat can stay here, keep his size. Let's give him a name. Forget to name. And now we need some things. So fantasy? Is there a UFO here? Because if there isn't, we're gonna find it. We're gonna make our own. We'll draw our own. Spaceship. Rocket ship. That could work. Do we want to try that? Let's try alien. Well, we can always draw our own. Here, let's paint. Eee. There's one. There's like the ring around it as well. That's our alien. How about that? Dun, dun, dun. So it's not sprite 1, but spaceship. Put little holes in it too if you wanted to, but this will be our spaceship. It will appear. Okay, so that's the first thing that we need to get started with. So when the program begins, when I click the green flag, the spaceship must appear. So we need to make sure that it is like hidden at the beginning, but we'll make it appear. We'll say show yourself. Because hide and show make things appear and disappear. We'll say show. And then we'll have it move down above the scratch cat. You see where I'm going with this? Move closer to the ground. And so we'll take its current coordinates, which is very convenient that it like changes the glide settings as you change the coordinates of the thing. It's beautiful. Actually, yeah, we'll talk about this in a second. We'll glide it down to this spot. That seems like a good spot. And then we need like a nice little tractor beam that can bring the cat up. So let's send out that beam. We might have to draw it. I don't know, do we have like a little light beam or anything? I do not immediately see it. No, I got nothing. Alright, let's draw it. New sprite, please. Paint. This is gonna look silly, but who cares? There's a beam side the beam. We should probably put, oops. I should undo because that's not really centered now, is it? If that's supposed to be the center, whatever this thing is, then we're in trouble. Can I like paint with a much larger brush? Yeah. I don't know what the color should be. Maybe like light. How's this? How's that for you? Here's our little tractor beam. That's pretty bad looking, but that's what's gonna have to work for us. Okay, so let's continue. So we'll call this like beam or something. So it needs to come out and it needs to like be transparent. I hope we can change that. Let's change the ghost effect by a certain amount. Oh yeah, that's much better. Does that seem like a nice little tractor beam amount for you guys? Maybe, how about that? That's good. So it's got to come out of the, like this needs to appear here. So it needs to show itself. So a lot of things are happening when the program starts. So we need time for the spaceship to come down. It'll take a second to get there. Glide. So after a second, the beam needs to come out. Okay, we'll send out the beam after a second, because we need to wait for the spaceship to come down. And then we'll make the beam appear. And then we'll test it all out. Okay, so let's hide the beam, hide the spaceship, or actually put it up here first, hide the spaceship, and now let's play this. So the spaceship should appear with the show, and then it should glide to the smaller, or down here, and then the beam should wait a second and show itself. So let's watch this. Whee, there it goes, and there it goes. Isn't that fun? Let's see. And it looks like it always resets its little effect, so let's make sure that it's Always nice and ghostly. So I can move this back. Click it again, comes down, shows itself, makes itself a ghost. And transparent. So again, you see that there's an issue of initialization. So we would like the spaceship to start out way up here and hidden. Yeah? So there it goes. Let's make it go right here. Make sure it's hidden as well before we do anything. Hide, go there, and then you can move. Same with this beam. It needs to start out. You can stay in its same spot, but it needs to start out hidden. You see that? Only after a second should it show itself. Click the green flag to run both programs. So now we're talking. So when we click the green flag for the spaceship, it moves to its initial position up here. It goes to where it should be. That's what the go to does. Then it shows itself and it glides down. Okay, that's watch just the spaceship. That's what happens for it. Then the beam, it starts out hidden, doesn't ever move. It waits 1 second to show itself because that's when the spaceship will be down there. And then it makes sure that it's nice and transparent. Maybe we can make it transparent before it shows itself. No, I guess it always... No, it's still transparent. We're good. Okay. So now we have this so far, this much. And remember that I'm going to give you these programs for you to study. Okay? So that's almost all the way there. Let's keep going. Okay. We need to glide the cat upwards now because he's getting abducted. So the cat, actually, we need like a backdrop. Let's have a nice, do we have like a farm? Yes, hayfield, of course, of course. This is perfect. Okay, so now the scratch cat needs to move up. Needs to be beamed up. All right, how are we going to do this? We need to give him a program. Okay, so events, when the green flag is clicked, we need the scratch cat to, well, how long are we waiting here? We need to wait it seems like 1 second, okay? After 1 second, the beam will appear. Then we make the scratch cat move up. So I think you know where I'm going with this. We need to initialize the cat. So let's make sure he starts out down here. So go to this position when you begin, cat. And then I want you to end up like up here after you get abducted, okay? So we'll take you 1 second to glide up there. And I think that's a bit too soon though, because it needs to, yeah, see how it's going up before the beam's down? We need to wait a second before we ever start the cat moving. So let's go down to the wait block. I hope you see how all these blocks are coming together. Wait a second. We should have the go to at the very beginning though. Boop, boop, boop. Yeah? See how this is working? I believe we would prefer to have the beam in the front. So let us make sure that is the case. I think if I just do that, the beam will be in front. Yes. And now we want the cat to disappear. We're almost home free. After this is all finished, we want the cat to disappear because he's gone inside of the spaceship. So we need to hide him. There he goes. Hide. Which means we need to start him out being shown. Because if I didn't have this show, watch what would happen if I run the program twice. Whee, he goes away. But now when I rerun it, he's still hidden. We need to start him out showing himself. Whee, up and away he goes. Then we want the beam to disappear after a second, because it takes a second for the cat to be abducted. So we'll wait another second. You see how this is all working? Wait a second, and then we should hide the beam. It was looks, wasn't it? Yeah. Hide the beam after a second. So now this is how far we've gotten. Up. Now the beam's gone. And now we want the spaceship to go up. And maybe hide itself after. So we're going to wait a second. I believe. We can try this. Wait 1 second, please. Then we'll move the spaceship up to here. Have it glide. not to a random position, but here. And then we can have the spaceship disappear. So goes down, comes up, goes up, and now let's have the spaceship finally disappear. I know that this is a complicated program, but that is kind of the point. I want to give this to you in class. So I confuse you in class and make you experts when you do it yourself. Okay? So this is the full program now. We've done it. So the cat starts out showing himself, initializes himself to the position down here, waits a second to be beamed up because that's how long the spaceship needs to come down and beam itself out. The spaceship begins by initializing itself, showing itself, gliding to a lower point so that it can abduct the cat, waiting a second, gliding back up after it's done its job, and hiding itself. Whee! That's the spaceship, and then the beam waits a second because the spaceship needs to come down first. Then it makes sure it's transparent, shows the beam shows itself, waits a second because that's how long it takes for the cat to get glided on up, and then it hides itself because its job is done. Whee! And away it goes. Okay, so that is alien abduction in a nutshell. That's a very complicated example. I'm going to eventually get you to be at this level, okay? But I really want you to study this. That's why I'm giving you all this code, okay? That's a fun little example, I hope. And that leads us to our first programming assignment. Okay, so let's go to that, and then we're all done. So programming assignment 0, because we like to start our numbers with 0 in computer science. For this assignment, I want you to go to this website called hourofcode.com, okay? And just do any of these. It's a nice little lesson, and it will look like this for you. And you can click any of these. Just do one. Flappy Bird is cool. I tried Dance Party. It's cool. Pick whichever one you want, and just upload a screenshot. Give me proof that you completed the activity. Okay, that's all I want you to do. It shouldn't take too long. It's just to get your feet wet with Scratch, because this most of this uses a form of Scratch. And yeah, just show me proof that you did it, and make sure that your code blocks are visible, of course, so that I can see that you did all this work and it's all correct. Okay, so that is your programming assignment 0. It shouldn't take too long, and yeah, go forth and do that. On the other hand, if you've already programmed, if you've taken CSCI 40 or some programming class, if you haven't, just do this, okay? You don't have to listen to me anymore. You can leave the classroom. You're free to go. If you've programmed before, I want you to contact me, okay? Because this is way too easy for you, okay? I don't want to bore you. I want to make sure that you're doing something that you like and that is good for your current level, okay? So we're going to come up with a custom programming assignment for you that suits your interests and abilities. And yeah, just please contact me, like on Discord or something, and we will come up with a nice suite of programming assignments for you, because all of them are going to be introductory ones otherwise, and you're a bit more advanced, I believe, if you've taken a programming class. So yeah, just please contact me if that applies to you. Otherwise, do the Hour of Code assignment. This will be due on the 21st at 5, so that's a Thursday. So I'm going to try and make programming assignments be due on Thursdays, writing assignments be due on Tuesdays, okay? Just to match the lectures. That's the idea. So you'll have like a week, assuming you watch this on the Thursday. Okay, so I think that's all I wanted to say. Good luck on your assignment. Please contact me. Come to office hours if you're having any trouble at all, and I will make sure that things start making sense. So I will see you next week.